In this video, we're going to take a look how to simplify roots of different powers. So first thinking about our vocab terms, this symbol here, that's a root or a radical. This number here, this 3, is your index, and the number inside the radical is your radicand. The goal when you are simplifying a radical is to take any number to the nth power out. So the nth meaning like the nth that matches your index. So let's say if I have the fifth root of 2 to the fifth, so since 2 is to the fifth power, 2 can come out of this radical. Okay, so that's what we're looking for, to see if we have any numbers raised to that exponent that's maybe hidden in this number here. So here we have the cubed root of 1029, x to the fifth, y to the sixth. There's a couple ways that we can figure out if there is a number to the third power in this root. So one way is to use Desmos. We have the third root, so you can type in x to the third and then make a table. So you hit the settings and then click on the table icon, and here we have a table. You want to change these numbers to be just like 1 through, you could go up as high as you want. So 3, 4, 5, 6, and we can keep going. But what we could do is use this table and see which of these numbers in the right column can divide into 1029. So one more. So 343 can divide into 1029. So I have the cubed root of 343, and 343 times 3 is equal to 1029. And then I'm going to write my variables out to be 1, 2, 3, 4, 5. So I'm just expanding them. And 1, 2, 3, 4, 5, 6. Okay, so 343 on this table, the left column tells you what number is being raised to the third power to give us 343. So 7 to the third power is 343. So since 7 is to the third power, so I'll rewrite that as 7 to the third power. And then those x's are the same. So since 7 is being raised to the third power, and that's the same as my index, then 7 can come out of the radical, and 3 would stay in. Another way to do this, I have 1029. We can make a prime factorization. So we want to see what prime numbers can go into 1029. So prime numbers meaning only one in itself can be multiplied. So numbers 1, 2, 3, 5, 7, 11, these are our prime numbers. And so for this first round, I see 3 can go into 1029. So I'll do 3, and 3 into 1029 is equal to 343. Next, I'll see can 3 go into that? So 3 cannot go into 343. How about 7? 7 can. 7 can 49 times. So 49. I know 7 can go into 49 7 times, and 7 can go into 7 once. So this is a prime factorization. So 3 times 7 times 7 times 7 is equal to 1029. So once you have your prime factorization, we look at our index, we're looking for groups of 3. So I have a group of 3 7s, and that means 1 7 can come out. 3 is not circled, so 3 stays in. So this is another way that we can do this. Okay, and then for our variables, so this index number is always telling us the groups that we're looking for. I'm looking for groups of 3. So here is one group of 3, and here's another group of 3, and another group of 3. So the same thing with the variables. For each group of 3, just one would come out. So an x can come out, and 2 y's can come out. So when I'm saying come out, it's coming out of this radical. So these are on the outside of the radical. I'm left with 2 x's on the inside. So just combining this information, we did the numbers first and then the variables. So our final answer would be this 7x. I wouldn't write this as yy, but y squared. And then the cubed root of 3x squared. And that would be my final answer for this.